Okay, geometry class. This is my second go at the video. It crashed on me again. This little app, if I go past 15 minutes, so I really got to watch my timer here. If I get close to 15 minutes, it sort of freezes up and it overloads. It crashes. So the notes, unfortunately, were already written out, but that might save me a little bit of time instead of slowing me down. So get out a pen or pencil. You guys have the ability to pause it at any point to catch up with the notes. So Geometry 9-10, trigonometric ratios. In trigonometry, we use it a lot. There's a lot of applications in trigonometry, from airplanes landing at O'Hare to building roads that lead in and out of O'Hare, expressways, ramps, all that kind of stuff. Trigonometry comes into play. It's a big, big, big part of construction, architecture, all sorts of applications, science applications, everything, construction especially. So trig gets used more than just what they showed you in 9-9 with the 30, 60, 90 and the 45, 45, 90 triangles. So there's a lot more to it than just those two. All right. Think of a right triangle, and as the acute angles, there's going to be one right angle and then two acute angles. As the acute angles change their sizes, as those change, then the sides of the triangle have to change, or vice versa. If I change the lengths of the three sides of the triangle, well, then the angles will have to change accordingly. That relationship between what size is the angles and how long are the sides, that is trigonometry. That is what it's all about. All right, so try this on a calculator. They have a table on page 424. I don't recommend it, but if you don't have a calculator that has a sine, cosine, tangent button, sine, cosine, tangent button. If you happen to not have a calculator with those buttons, there's a table on page 424 for you. But you could try the sine of 23 degrees. Sine 23 degrees. I got to make sure I'm in the right mode. I'm in the wrong mode. So I was in what's known as radian mode. They get to use in a bigger trigonometry class. We want to make sure we're in degree mode. Some of your calculators just needs it to say DEG. So you want to make sure you're in the right mode. This one was in the wrong mode and would have given me the wrong number. But the sine of 23 degrees is going to be equal to, and you get a very long decimal, depending on your calculator and how many digits it wants to go to. Most times for problems like this, they say 3 or 4 decimal places. Don't stop at 1. That'll be an awful answer. Even 2 is a little bit too short. 3 or 4 decimal places, usually 4. When you're asked for what's the sine of 23 degrees, what's the sine of 57, what's cosine of 80 degrees, anything like that. So you can punch any of them in. I just said cosine 80 degrees. Cosine 80 degrees, 0.173. You get these little decimals. Those answers are when they take the, like for sine, opposite over hypotenuse, and you actually divide the fraction out, it would be this decimal. If I did cosine, it would be the adjacent leg divided by the hypotenuse would give me that decimal. So these calculators, these little functions, help us get those decimal answers right away. For application problems, we need to understand two phrases: angle of elevation versus angle of depression. Angle of elevation versus angle of depression. The important part is that you have to use a horizontal line. I'll use the back of these other notes. You got to use a horizontal line going straight across. Horizontal line. Let's say it's a sidewalk, and then you're looking up at a balloon in the sky. All right, or you're on top of a building. All right, and you tilt your head down to look at something down on the ground. If you're looking up, they'll call that an angle of elevation. Horizontal line and up. Always horizontal line. Or horizontal line and looking down, that's an angle of depression. That's an angle of depression. Angle of elevation, angle of depression. One and the other. All right, so let me take a different word problem here. Or I had this one all written out. I'll give you a different example now. So example, we'll call it example 1. using trigonometry. So I'll save this for the word problem later. Angle of elevation, angle of depression, for the word problem later on. If I give you a right triangle, and I'm just going to use one of our common right triangles, 5, 12, 13. We can actually use trigonometry. We can use trigonometry to actually figure out what is the degree number here if I know what the sides are. And sometimes they only give you 2 of the sides. I'll demonstrate that in the next problem. And then you have to figure out which trig ratio should you use. This one, I could pick any trig ratio because I got all 3 sides. I can go, hey, the sine of angle D we know is equal to 5 over opposite over hypotenuse, 5 over 13. If you know what the ratio is, because you got both numbers, you can find the angle by using something known as sine inverse, and then put the ratio in there, and it will tell you what the angle measure is in degrees. On our calculators, let's see mine. On and most calculators do it this way. Wherever your sine, cosine, tangent buttons are, right above it is the inverse button. Sine inverse, cosine inverse, tan inverse. So I got to use second, like the second function for the button, sine inverse, and then I put in my fraction, 5 divided by 13, sine inverse 5/13, and it'll tell me the degree number. In this case, it's about 22 point. Now, degrees, they usually just say, all right, 2 decimal places is fine. And I'm going to put approximately. That's the measure of angle D. Now, I picked sine randomly. I could have picked any trig ratio because I got all the sides. So, for example, if I picked the cosine of angle D, that would have been 12 over 13. If I do cosine inverse 12 over 13, that should give me the measure of angle D, and I should get the exact same number. I use a different trig ratio, but I use a different trig function, cosine, but that uses a different ratio. 12 over 13 is compared to 5 over 13. If I did second cosine inverse, so maybe some kids use cosine instead of sine. It wouldn't matter. It would give us the exact same decimal, 22.62. I could use it to find angle R. I can do cosine of angle R is 5 over 13. Do cosine inverse, and it would give me this number. Although if I know this is 22.62 and that one's 90, subtract them from 180, I can get that angle. I can get that angle anyway. All right, let's try another example. Example 2 is an example where you have to figure out, this is more normal. This is a more normal example. You have to figure out what trig ratio should I use? What trig ratio should I use? So like if this is X, that's 24 degrees, and this is 20, and it says solve for X. You got to figure out, well, if the angle is here, which SOHCAHTOA, sine, cosine, or tangent, which one should I use? It all depends on what pieces we're given. That angle, opposite, hypotenuse. Well, the only one that uses opposite and hypotenuse is sine. So you can do the sine of 24 degrees is equal to opposite X and 20 on the bottom. Multiply whatever's on the denominator. Sometimes it's X, and you got to multiply X and get it out of the bottom. But multiply by 20 on both sides. And I can do that directly on a calculator. I can go 20 times sine 24 degrees, and it'll give me what X equals. We got to round it. We'll call 2 decimal places, 8.13. I'm sorry, it's a little dark on the screen there. 8.13. I just did 20 times the sine of 24. It'll give me what X equals. 8.13 feet, inches, meters, whatever that would happen to be. Okay. And this next one, I'm going to do this quick so that I have more time to show the math work. This is where I ran out of time and the whole video crashed on me before. Pause it right now. Copy that down. Pause it, copy it down. You're standing on a cliff 360 meters above sea level when you look down at a ship out at sea, if your angle of depression is 28 degrees, angle of depression is 28 degrees, then how far is the ship straight out horizontally from the face of the cliff? I want you to take 30 seconds, pause it, and try to make a diagram. You don't have to solve it yet. Just try to make a diagram. What would this look like? Label all the numbers. Pause it. All right, this is what it would be. You have a cliff, water. Here you are up on the cliff. You're looking down. There's a boat. There's a boat going by in the water. You spot it at an angle of depression. Now you are 360 meters above, so that's this line. We're looking for this line. How far out is the boat from the face of the cliff? Everybody who tries this, when they first try it, they get the angle of depressions wrong because they want to draw this triangle and they want to stick 28 right here. Angles of elevation and depression must be made with a horizontal line. So if you were looking straight out and then angle your head down or your eyes down, and that's at a 28-degree angle of depression, that's outside of my triangle. So I got two ways I could do this. I could use alternate interior angles, make a big Z. These angles would be congruent, 28 here, 28 down here. And now I got an angle in the triangle. What I like to do is say this corner, if this was a big rectangle, this whole corner would be 90 degrees. So I take 90 minus 28, find the complement, and I get 62 degrees. I'm going to use 62 degrees here. Okay? This problem will work either way if I use 62 in this corner or if I put 28 in that corner. It will work. Now, which trig ratio should I use? 62 here, opposite, and adjacent. No hypotenuse used. Well, that means I got to use tangent of 62 degrees is equal to the opposite over the adjacent. Opposite over the adjacent. So that would mean multiply 360, and that would cancel. X would equal, let's do approximate because we know we're going to have to round. All right, let me get this so you guys can see it. But it's going to be 360 times the tangent of 62 degrees. 360 times the tangent of 62. Sorry for the glare. It's my little spotlight. And I get an answer that is approximately 677, I could say 0.06 meters. If I had approached the problem differently and I said, I'm going to use alternate interior angles. I'm going to make that Z shape. This is 28, and I have opposite and adjacent. I would still use tangent, but it would look different. Tangent of 28 degrees is going to be equal to opposite 360 over the adjacent. And so the work is a little different. I multiply x on both sides, get it out of the denominator. X times tan 28 equals 360. Then divide by tan 28. That's important. The tangent's actually on the bottom now. When I plug that in, I do 360 divided by tangent of 28 degrees. It should still give me the exact same answer. Oh, let me get out my screen here. 360 divided by the tangent of 28 degrees. Let's hit enter. Bam. Exact same number. You can even see the decimals still on the screen here. All right, I got to wrap up the video here. I got it all in one video. Gosh, I hope it works this time, because I don't think I'm going to do a take 3 this late at night. All right, guys, if you have questions, let me know.